So this is our learning objective for this class. First of all, we'll go through 5G deployment options. So we have many options to deploy 5G. No such options were available in LTE. Whenever we talk about LTE, we talk about LTE core, we talk about LTE RAN, we talk about LTE node Bs, everything LTE, right? But in 5G, it is a little bit different. So in 5G, yes, there can be 5G core, 5G G node Bs, and 5G RAN completely. But in addition to that, there may be one more option called NSA, which is non-standalone mode. So with the help of 5G G node B and 4G core, we can deploy 5G as soon as possible, right? So it will help us to deploy 5G faster. So that we'll see in this 5G deployment options. So what's the objective of this part? So in this part, we'll talk about dual connectivity feature. So what is dual connectivity? And we'll also explore the advantage of dual connectivity. In addition to that, we'll discuss the various architectural options for the 5G dual connectivity, right? And we'll talk about some concepts related to multi-radio dual connectivity as well, okay? And in the end, we'll list the various 5G multi-radio dual connectivity deployment options. So as I said earlier that in case of 5G, there will be standalone options and there will be non-standalone options as well. Okay, so we'll talk about all those options in this chapter, which is 5G deployment options. So let's begin. So first of all, what is dual connectivity, right? So you can see here the definition of dual connectivity. So dual connectivity is ability and capability to transmit and receive two streams of data packets from two radios simultaneously, right? So TX and RX, right? So capability to transmit and receive two streams of data packets from two radios simultaneously. So we should have two transmitters and we should have receivers as well. Okay, so this is the dual connectivity. So dual connectivity can be with the help of LTE, with the help of 5G, with the help of Wi-Fi as well, anything, right? But it is always called dual connectivity, right? So if 5G is connected with the LTE, that is called dual connectivity. 5G is connected with 5G, that is also called dual connectivity. If 5G is connected with Wi-Fi, that is also called the dual connectivity. So you can see in the figure two terms. One is MN and one is SN. So what is MN? So MN is the master node. And what is SN? SN is the secondary node. So what's the difference between this master node and the secondary node? So this is called master node. Why this is called master node? So in telecom, you heard of two planes. One is control plane and second one is the user plane. Why it is called master node? Because this MN controls control plane as well as user plane. So it has user plane signaling, control plane signaling, both of signaling it has. That's why it is called master node. Okay. The second thing you see here is the secondary node. Why it is called secondary node? Because it has control only for the user plane. Okay, that's why it is called the secondary node. Okay, so these two terms. So I want to introduce these two terms. One is MN, which is master node, and second one is the SN, which is the secondary node. Also, you can see here, I have two carriers. One is F1 carrier and one is F2 carrier, right? So this master node has both carriers. You can see here the blue one and the red one. So master node has two carriers, F1 and F2. Secondary node also have two carriers. One is, you can see here the blue and the pink one, F1 and F2. Okay, this is the other thing that they have both. So it is little bit different from the carrier aggregation, right? In case of carrier aggregation, we have only one BTS. In case of carrier aggregation, we have only one scheduler. But here I have 2 BTS, or you can say I have 2 schedulers. Okay. In addition to that, you can see here my core network. My core network is connected to both master node as well as secondary node. Okay. And you can see here my UE, my 5G UE, that is also connected to master node as well as secondary node. Okay. So this is the dual connectivity. So this master node. So when to add secondary node, how to add the secondary node, how many secondary nodes to be added, all controlled by the master node. Okay. So first important terminology, master node and the secondary node for this dual connectivity. All right, between the 2 base stations. Okay. Then we have this dual connectivity concept, right? Then we have this dual connectivity concept. So we have the master node, right? And we have the secondary node that we have talked about. What about the cells that belongs to these nodes? Well, all the cells that belongs to the master node are called master cell group. You can see here one term called MCG. These are called the master cell group. All right. So group of cells served by the master node are called the master cell group or MCG. And we are going to have one cell called the primary cell. That is the primary cell of the MCG or the master cell group. And we will have the secondary cells as well, right? So we can have various secondary cells. Okay. So we can do carrier aggregation between P cells, S cell 1, S cell 2, that we can do. Okay. So we can do carrier aggregation between the primary cell and one or more secondary cells that belongs to the master node. Okay. So one big thing about primary, why this is called the primary cell? This is called the primary cell because this is the signaling anchor. This is the signaling anchor. It has the RRC connection. Okay, it has the RRC connection. That's why it is called the primary cell. Then we have this secondary node, right? This secondary node. And if all these cells belongs to it, we call that secondary cell group. Okay, that is called SCG. So group of cells served by the secondary node are called the secondary cell group. And we also have a primary cell. We call it a PS cell. Okay, so we stick here a new term called S, right? So you can see here one S here, right? So PS cell. So what's the function of this S? Just to denote that it belongs to the secondary node. That's why it is called the PS cell. Then we also have S cells, and we can do carrier aggregation between the PS cell and one or more S cell of the secondary node. Okay, so just introducing new terminologies like master node, secondary node, master cell group, and the secondary cell group. Okay, for the multi-rat dual connectivity. Okay, at the high level, I can say that when we do carrier aggregation, right? When we do the carrier aggregation, so if we have one BTS, right? If we have one BTS, then, and if we have two carriers like F1 and F2, then we do carrier aggregate between F1 and F2. But in this case, I have only one scheduler. Okay, I have only one scheduler, or you can say scheduler one. But with the help of dual connectivity, I have two BTS. One is from LTE, and second one may be from the 5G, right? So if we have two carriers, maybe F1, F2 here, and two carriers in case of 5G, maybe F3, F4 here, right? In that case, we have four carriers, F1 plus F2 plus F3 plus F4, right? So we can have carrier aggregation between the four carriers. Okay, so this is a little bit difference between dual connectivity. So in case of carrier aggregation only, we have one scheduler, but in case of Dual connectivity, we have more than one scheduler. Okay, so this is the dual connectivity. So now the question comes, why we need dual connectivity? The main reason of dual connectivity is to provide more radio resources to users and the user equipment. So we found this, what is really important in sales and the marketing and in the competition is the services in the end, right? What kind of services we can give to our customers, especially in the competitive world. So how can I differentiate my services as an operator versus the another operator? How it is better? Well, do we really need market nowadays? So we market what? We market speed, right? High data speeds, really good application performance, right? 70% of the traffic on the internet as of now is the video content. And video, as you know, is the fairly bandwidth intensive application. And it requires a lots of bandwidth versus, you can say, looking at the web pages, reading emails, or, things like that, texting, etc. So speed matters, all right? So dual connectivity gives us the option to provide more radio resources to the user equipment that can result in the improved throughput, give us better capacity, better coverage, give us the ability to manage load across different carriers and BTSs. So you can see here, we have various reasons for dual connectivity on this slide. So one reason is the capacity. One reason is the throughput, right? So can I increase the capacity with the help of dual connectivity? The answer is yes. So capacity is very interesting word, right? So capacity could be user capacity, capacity could be throughput capacity, right? So can I give more and more throughput to a user? Answer is yes, because I can push more and more data. Also, can you support more subscribers? Answer is yes, right? So in both ways, I can use the user capacity and the throughput capacity as well. Then we have this mobility control. Right? We have this mobility control. So how can dual connectivity minimize the handover failure rate? So that is where your mobility comes into picture, right? So here you should articulate one interesting point. So there is something just single connectivity to dual connectivity handover. So what do you mean by that? So initially I have only one base station at a given point of time and I'm providing this service. But what can I do this? I will hand over in such a way that you will provide dual connectivity, right? That means two base stations are going to provide the connectivity. So in this case, what happens is handover success rate will increase. Our handover rates will typically comes down. So that is where your mobility control comes in this one scenario. Okay, so with the help of dual connectivity, our handover failures will come down. So that is what is very, very important for the mobile networks, right? So that where your mobility control comes, which is very, very important for telecom, and I mean as an operator, right? So this is very interesting philosophy. And then coming to the coverage. So when you talk about coverage, we talk about the heterogeneous network, small cells interworking with the macro cells. And all those things will come to the part of the coverage typically, right? So with macro cells, my coverage will go maybe between maybe 5 to 3 kilometers. But when we have micro cells or pico cells, you can typically provide the coverage extensions with a better quality of service with the help of dual connectivity, right? So moreover, in case of 5G, we have various bands like low bands, mid bands, high bands. The lower frequency, or you can say 600 megahertz, 700 megahertz, has more wider coverage, because if signal connection is not good, service is not good, right? So first aim is to have coverage, but these low bands are generally occupied by the LTE, So with the help of dual connectivity, we can use LTE bands and we can improve the coverage. So it's really important to have that signaling connection right on the best coverage layer. Okay, so what you want to do is you want to put the master node on the coverage layer that has the best coverage, right? And we know that you can have higher frequencies for improving the data rates. So with the help of lower frequencies, you can get the ubiquitous coverage for the master node, right? And then you can go ahead and use the resources for the secondary nodes to improve the data rate. Then we have this load balancing. So what's the main aim of load balancing? So the main aim of load balancing is to balance the uneven traffic load among the neighboring cells. In the wireless network, traffic load in different cells is frequently unequal. You know it, right? Some candidates get very high traffic, some candidates get very low traffic. So what happens? It brings about higher call blocking rate and higher call dropping rate in the hotspot cells. So in contrast, a large part of resources in the low loaded cells stays in the idle state, or you can say they are unutilized, or you can say underutilized. So it will result in the wasted resources and decrease network throughput. And because of that, our network performance seriously deteriorated by the load imbalance among the neighboring cells. So that's why load balancing plays an important role in improving the user experience and network performance by redistributing the traffic load among the neighboring cells. Okay, so load balancing is one of the other benefit of the dual connectivity. And so, of course, finally, we boil down to optimal network performance. The best network performance, right? So flexible use of radio resources. So here the word radio resources, very interesting, right? So as a RAN person or a radio person, we always talk about how best we can utilize the radio resources, right? So it could be LTE, or it could be 5G, it could be 3G, it could be 2G, but our main aim is to efficiently use our radio resources. So we make sure that radio resources should never get wasted, right? For which we can plan the network. We also make sure take the advantage of dual connectivity. So if one base station is overloaded, then I will offload to other base station. It could be Wi-Fi offloading, it could be 4G offloading, doesn't matter. But the philosophy is typically a part of the dual connectivity. So again, guys, when you talk about dual connectivity, you are connecting two different base stations to a UE. So what is the gain I'm going to get, right? So these are all the different gains I'm going to get. I can get better coverage, I can get better loading balancing between the base stations or the towers, or what. Also, you can get here better capacity, better throughput. Finally, also we can have better mobility control, which is nothing but your handover failures can be minimized, right? Our handover success rate can be increased, whatever, right? So these are all the interesting things, right? So these are the benefits when we talk about the dual connectivity. And one more thing that I want to mention here that is not mentioned in this slide. So dual connectivity, there are two more benefits of the dual connectivity, like time to market, right? So faster time to market. And the second important reason is lower cost of deployment. Okay, so I argue that these are actually the two biggest benefits, and you can do this through the picking up this dual connectivity options. So some dual connectivity option doesn't require 5G core network, so that's a big deal, okay, right? So I will have 5G rollout quicker without investing in the 5G core, and we'll go through that in just a little bit. So these are the benefits of the dual connectivity. Okay. Okay, so let's talk about E and DC main principles. So you see here one term called E and DC, right? So what's the meaning of this E and DC? So what is this E? So E is E-UTRA, or you can say LTE, right? And N is the NR, right? N is the NR, or you can say new radio, or you can say 5G. And the DC is the dual connectivity, right? Okay, so E and DC, E-UTRA and new radio, dual connectivity. Okay, this is the meaning of this E and DC. So what are the main principles? So first of all, as I said, E and DC stands for E-UTRA and new radio, dual connectivity. So it allows user equipment to connect to an LTE E node B that acts as a master node and a 5G G node B that will act as a secondary node. Okay, and it is typically used to boost the capacity and the data rates for the end users. So using E and DC, devices can both access LTE and 5G simultaneously on the same or the different spectrum. In this way, we can have dual connectivity. And in this, we have two possibilities. So UE can be simultaneously connected to LTE and NR, or UE may connect to the LTE for control plane and NR for the user plane. So again, as I said earlier, there will be connection between the base stations, and the two base stations can be connected to the UE as well. Okay, so connection between the base station as well, and connection between the UE to both the base station as well in case of dual connectivity. And you can see here one term called MRDC, which is very similar to ENDC, which is called multi-rad dual connectivity. Okay, this is called multi-rad dual connectivity. In this, UE is connected to one E node B that act as a master node, and ENG and then we have this ENG node B that act as a secondary node, right? You see here one term called ENG node B, one is E node B, right? And you can see here I'm using the EPC, which is LTE core, right? Which is LTE core. You can see here between G node B and E node B, there is an interface called X2 interface, and between G node B and G node B, there is X2 user plane interface, right? And between E node B and core, there is an S1 interface, and between E node B, G node B, and this core is user plane interface only. Okay, so you see here one term called E and G node B. We'll talk about later. We'll talk about this term in a little bit. So, but just remember that there is a term called E and G node B. Okay, for this moment, don't think of only E node B. Think of this term as E node G node B. Okay, so this is the E and DC main principles. 5G dual connectivity architecture options. So here in dual connectivity, we have four possibilities. Okay, so we can divide it into two parts. One is like this. You can say this is A part and this is the B part. Okay, so I have divided into two parts, partition. This is EPC and this is, so you can see here in this part, I'm using the LTE core, which is EPC, right? LTE core. And here I'm using the 5G core, right? So in the first part, right now I'm talking about this thing, which is called E-UTRA. Let me change the color. Maybe I can put here the green color. So right now I'm talking about this part. Okay. So first one is E and DC, right? So frankly speaking, this is the one that I see being dominant today. All right. So that is already been launched, mostly used by the existing LTE carriers. All right. So first of all, here no 5G core. This is the 4G EPC. All right. And so this option allows an existing LTE operator to deploy the 5G RAN without using the 5G core. And that is very different than when we roll out the LTE. So because when we rolled out LTE, we had to deploy the RAN, the core of LTE only, right, at the same time. So this stands out. And so because we don't have a 5G core, the big thing here is the G node B has to understand the 5G protocols. So you can see here, there is one term called G node B, and G node B is connected to the EPC, right? So G node B is connected to the EPC. And you can see here one term called EN. So what's the meaning of this EN G node B? So you must have heard of term G node B a lot, but why we add this term EN with this G node B? Because the G node B is connected to the 5G core. So to work, if G node B wants to work with the 5G, with the LTE core, it has to understand the 4G protocols as well, right? That's why it is called EN G node B, not only G node B. Okay, that's why it is called EN G node B. So here, E node B is the master node, and this G node B is the secondary node. So imagine you are already existing LTE carriers. You got ubiquitous coverage in the country where you are operating, and those are going to be the master nodes. So you are going to co-site G node B, and it will be called EN G node B, right? And it stands for E-UTRA new radio. All right. So again, what's the meaning EN G node B? That it understands the 4G protocols. It has to. So whatever we are going to do this, so we are going to interconnect those with the help of this X2 interface. Okay, you may have heard of this interface a lot when you do the LTE. So E node B, E node B and EN G node B are connected through the X2 interface, right? So we know that X2 is the E node B to E node B connection that is widely used from the beginning of LTE for doing handover between the base stations. So X2 is not a 5G interface, it's a 4G interface. All right. So now the G node B has to understand the X2, and it also has to understand the S1 because this is 4G. So big takeaway, we are going to deploy 5G RAN on the top of 4G RAN or co-site them, and the 5G node has to know the 4G protocols. That's why it is called the EN G node B. Okay. So this is this option. So let's talk about the part B. Now we'll talk about this option. Okay. So the next three options here, we are all going to depend on the 5G core. So we'll have to roll out the 5G core for these options here and for the next generation dual connectivity. So you can see here this option. So here we are going to notice we have NG E node B and we have this G node B. So we can notice here that NG E node B is the master node and G node B is the secondary node. And these are connected through with the help of this XN interface, right? But the XN is the 5G interface, right? For the connection between the two base stations. So here you can see here the term NG E node B. So here the E node B has to speak 5G protocols. All right. So in previous case, we made the G node B backwards compatible with the 4G. But here in this case, we are going to make the E node B forward compatible with the 5G protocols. That's why it is called NG E node B. So this is a difference here. So we have got NG E node B now called next generation E node B. It is still an E node B. It is still the LTE based, but it understands 5G protocols and connected through the XN interface, which is a 5G interface. Okay, so this is the other option we have. The third option we have is this option. So we are going to do this. We are going to flip in this option. We are going to flip flop the roles of G node B and E node B. You can see here G node B is the master node and E node B is the secondary node. Okay, so it is still NG E node B. It means still it has to understand the 5G protocols. Still it is connected to the XN interface. Only difference is that in this G node B is the master node, so it will have both control plane and the user plane signaling, but the NG E node B only has the user plane signaling. So this is the difference between the third option. And in the fourth option, you can see here NR dual connectivities. You can see the name here, NR dual connectivity. So what do we have here in this option? We have a G node B is the master node and the G node B only is the secondary node. Theoretically, this is like multiple years out in the future, maybe 5, 6, 7, 8 years. It could be 10 years in the future. So guess what happened in this case? 4G technology is gone. So here you will have just 5G. So what is the situation today with the UMTS and LTE? Also, a lot of operators today have basically already gotten rid of the 3G. They have already got rid of UMTS, 2G or CDMA. If you remember, they are all LTE and it takes time to do that. Many operators, as you know, I would call it like 90% on 4G and maybe 10% on 3G. And I don't think anybody is on 2G in the whole world. And that, you know, depends on the operator, on the country, and how fast things move in those countries. But it is already happening, and that is what we are going to happen over time with the 5G as well. So although LTE is a long-term evaluation, long-term evolution, so expect 4G to last for a long time. Okay. So this is an option where you don't have any 4G there. Okay, so these are the few things these are the few architecture options in case of 5G. So here are the standard different options listed by 3GPP based on the theory we have just discussed. So I just want to point out a couple of things before start getting into them deeply. So at the top, we have options, option 1, option 2, and the option 5. And these options are also called the standalone options. Okay, so these options are called the standalone options. And what that means is that when we deploy the network, for example, in option 1, here you see the E node B in terms of the RAN. So we only have the 4G RAN. So there it stands on its own, can communicate with the core, the EPC, right? So we have only LTE EPC, we have LTE E node B. So only standalone mode. Okay. So option 2, that is also a standalone mode. In this case, we are using the core of 5G. We are using the RAN of 5G, which is also called G node B. And that is also called the standalone option. We have core, we have G node B, and also have N interfaces, which is 5G interface. Just communicate with the 5G core only. Okay. And then we have this option 5. So we now have 4G radio, right? You can see here the 4G radio access talking to the 5G network. So in this case, the E node B has been upgraded with the help of software. As I told earlier, it can be upgraded with the help of software to allow it to understand the 5G interfaces and the protocols. So this is also a standalone option. Okay. So in this would be called a next generation, as I told you, NG E node B, right? So what is NG node B? The node which can understand the 5G protocols. So now these are the standalone options at the top. On the bottom, you see here some options like option 3, option 4, option 7. So these are the non-standalone options. So what you will notice here is that we have two types of radio access technologies or radio access network. Okay. So in those options, what stands out is that new technology we are introducing. For example, in case of option 3, you will see here we are using the 4G core. and we are introducing the 5G RAN. In case of option 4, we are using the 5G core, but in that case, E node B act as a secondary node and G node B act as a master node. And the third option you have is the option 7. In this case, E node B is the master node and G node B is the secondary node. Okay, so these are the few options that are suggested by 3GPP based on the options, based on the theory we have discussed in the previous slide. Okay, so these are the options that are suggested by 3GPP. So we have seen many options proposed by 3GPP, and out of those, only these options are mainly used, which is option 1, option 3, and option 2 at this moment. All of the options may be used in the future, but at this moment, most operators are giving attention to these 3 options. So you can see here, we have option 1, that is LTE. So that time 5G was not there. So in case of option 1, we are using LTE core, LTE E node B, LTE interfaces, everything. In case of option 2, we are using the 5G core, 5G G node B, and everything 5G. But as you know that 5G is a very advanced technology as compared to 4G. So it is not easy to migrate from LTE to 5G. So 3GPP people, or the people who decide these protocols and everything, they have reached a middle path. Okay, they have reached a middle path that let's don't jump to 5G immediately with the 5G core G node B. Let's have a middle path. Okay, so they have suggested a middle path which is called the option 3X, or you can say non-standalone mode. So with the help of non-standalone mode, we can launch 5G immediately. Just introduce the G node B as a secondary node. No need to change the core, no need to change the control plane and these things. But this UE should be capable. UE should be 5G as well as 4G capable, but not many things to change, right? So when you think about non-standalone option, so today as a wireless operator, you have a 4G LTE core and you have E node Bs and your radio access network for LTE that is deployed and be available today. So why to construct a new infrastructure? Let's use LTE core in the beginning. That's why option 3 is the preferred choice at this moment. Okay, so these are the things. These are the preferred choice. So let's see in more details about these options. This is the option 1. So option 1 we have discussed like end-to-end LTE, right? So LTE core, LTE RAN, LTE interfaces. So this is a straightforward LTE. If you are an LTE operator today, you are end-to-end operator. So when you have got your own radio access network, your own EPC. So this option 1 architecture today is the starting point. Then we have this option 2. Option 2 is end-to-end 5G, end-to-end 5G protocols, end-to-end 5G interfaces. Okay, so that is our 5G option 2. And then we have this option 3, or you can say option 3X, which is a non-standalone option, right? This is a non-standalone option. So in 3X option, you see a new 5G G node B, right? You see here our 5G G node B. So that G node B would be connected into 4G LTE core and also to its peer E node B, right? So it can be connected to this and the E node B as well. So we can provide, and then from this 5G G node B, I can provide the radio access as well, right? So we can provide the new radio communication over the air interface, right? So in that case, this is called the non-standalone, as I mentioned, or you can say NSA, non-standalone option. So that you will see people use this as an acronym, right? So in the standards, people have called it 3X, option 3X. So if you see people talk about option 3X, or if you see people talking about NSA, one of the things they are talking about is leveraging the existing 4G LTE core and existing E node Bs, and then deploying new G node Bs so that they can communicate to the 5G devices. Since LTE here is the master, UE established the RRC connection with the G node B, not with E node B. Okay, so RRC connection between UE and the E node B. Okay, so again, NSA option 3X ENDC architecture. Okay, so ENDC, as I told you, is the E-UTRA new radio dual connectivity. And then we talked about the master node, and we have talked about the secondary node. And why it is called the master node? Because it has the control plane connectivity with the core. You can see here I have connectivity with the core, right? Control plane connectivity with the core, because this E node B, which is LTE, and it is connected to the EPC through the control plane. You can see S1 MME, which is the control plane connectivity. And the G node B, why it is called the secondary? Because it has only the user plane connectivity with the LTE core. Okay, that's why it is called the secondary, right? So master node has both control plane as well as user plane connectivity, but in case of secondary, it has only user plane connectivity with the 4G EPC. So E node B has different scheduler for the device, and G node B has different scheduler for the device. That's why it is called the dual connectivity. We don't call it carrier aggregation, we call it dual connectivity, or you can say advanced version of the carrier aggregation. So in carrier aggregation, we have only one scheduler, but in case of dual connectivity, we have more than one scheduler for the same device. So data transmit between G node B and the LT core, but control plane and data transmit can be between E node B and the 4G core. So as I said earlier, there will be RFC connection between LTE and UE only. Okay, so there will not be any RFC connection between UE and the G node B. You know, there is a called data radio bearer, right? So there will be only a data radio bearer between the G node B and the UE. There will not be any RRC connection. Data radio bearer. So you have heard of terms called like SRB, SRB1, SRB2, right? So there will be only SRB1 and SRB2 is only between LTE and the UE, not between 5G and the UE. Okay, let me write it here. SRB1. Second thing is SRB2. Okay, so here main purpose is to improve the data rate. From LTE, we already have wide coverage. So with the help of just adding the G node B and by not changing the infrastructure much, we can increase the data rate. Only condition is that this UE should be LTE and 5G capable. So these are the few highlights for this 3X mode. So first of all, the UE should be capable for MRDC, right? So in this case, master node is the E node B, secondary node is the G node B. So we are using the core network of 4G, that is called EPC, which is called Evolved Packet Core. But the problem here in the 3X mode, in 5G, we have various features like network slicing, cloud computing, virtualization. These functions with the help of in this 3X architecture. Okay, so these things we lack in case of 3X. So let's talk about the key building blocks of option 3X. So with the help of LTE, you know that our maximum bandwidth can go up to 20 megahertz, right? But with the help of 5G, for FR1, our maximum bandwidth is 100 megahertz, right? And for FR2, our maximum bandwidth can go, in most cases, 400 megahertz, right? So with the help of LTE, we can improve our coverage, we can have ubiquitous coverage. But with the help of that 5G, we can improve our data rate. So UE can be connected to both LTE and 5G, and so coverage will be improved as well as data rate will be improved, right? And you can see here, because 5G supports low band, mid band, and high band, so we can improve our coverage, we can improve our data rate as I already said that in case of 5G, we have bandwidth that can go up to 400 megahertz, right? In case of LTE, it can go maximum 20 megahertz. So in case of LTE, we can do carrier aggregation of 5, right? Maximum carrier aggregation of 5. And as I said, maximum bandwidth is 20. So 5 into 20. So maximum bandwidth in case of LTE can go up to 100 megahertz, right? With the help of carrier aggregation, right? With the help of carrier aggregation, it can go maximum 100 megahertz. But in case of 5G, we can have bandwidth of 400 megahertz, right? So in case of 5G, 16 component carriers can be aggregated. So in case of 5G, you can see is 14 into 16. So 6400 megahertz, or you can say 6.4 gigahertz, right? So that's a huge difference from 100 megahertz to 6.4 gigahertz, right? So that way you can do it. Okay. And then we have this beamforming and MIMO. That's a good facility, good technique we can use to improve our signer. Also, in case of 5G, we have this split G node B as well. So you may have heard of that CU and DU, right? Centralized unit and the distributed unit, right? So G node B is divided into two parts. One is centralized unit and one is DU unit. So the lower layers like physical layer, or you can say MAC layer, RLC layer, right? Physical, MAC or RLC layer. Those layers we put in the distributed unit, and higher layers, right? Like SDAP, which is Service Data Adaptation Protocol layer. So that is a new layer we'll talk about. We may not talk about in this session, but that is a new protocol that is introduced in case of 5G for the quality of service flow. Okay, and then SDAP and PDCP, and the third one is the RRC, right? So at DU, lower layers can be functional, that physical, MAC and RLC. In case of centralized unit, SDAP, PDCP and RRC can function. Okay, so this is what I was talking about, that it is divided into two parts. One is CU and one is DU. At DU, these layers will work. At the CU, these layers will work. Okay. Okay. So let's have a quiz. Let's see if you understand what I was talking about. So let's see. So guys, can you answer these questions? So you can say here like question number 1, question number 2, question number 3, question number 4. So it's a true false answer. True false. So first question is that a UE with the multi-RAT dual connectivity capabilities is required for NSA option 3X. So if you agree with this, please write true. If you don't agree with this, please write false. Very nice. Everybody has said true. Yeah, and yes. If dual connectivity UE is not there, it will not work. Very nice. It's a true answer. The second question is that a 5G core network is required for NSA option 3X deployment. Okay, let's talk about the second question. Very nice, guys. Everybody has given the right answer. So it means you are following the course. Thanks a lot. So in case of 3X, we have seen that an LTE core is required, not the 5G core. And the third question is that the X2 interface is required to connect E node B and G node B in the 3X option, right? So is it true or false? Please let me know. That's great. You are right. There is an X2 interface required between E node B and G node B. And the last question is that in the option 3X deployment scenarios, a UE establish RRC connection with G node B, and G node B becomes the master node. So answer is false, because here E node B has an RRC connection with UE and E node B becomes the master node. Okay, so answer is false for this. Okay, thanks guys for the right answer. So the UE in NSA option 3X configuration maintains the signaling connection between the E node B, right, and may have data connection with between 4G LTE and 5G NR simultaneously, right? So in this case, UE capability is required and inquired by E node B and directing UE to the measuring neighboring 5G cells, right? And UE reports 5G cells for add, remove, or for the handover. So option 3X is an option with data split in the 5G E node B, and the data received from EPC is divided by the 5G G node B between the 5G radio and the LTE E node B. And this is usually favored as it minimizes the investment on the LTE side. Typically, the LTE E node B has not been dimensioned to handle very high data rates. But with the help of 5G, we can increase the data rate. That's why it is a favored option, right? And 3x is the most favored option to increase the broadband speed, or you can see the throughput. Okay. So option 3 is the dual connectivity deployment that we have seen. In this, LTE is the anchor RAT and NR act as a secondary RAT. So it is a non-standalone configuration based on the existing EPC. So both 5G base stations and the LTE base stations are connected to the EPC, but the control plane goes through LTE, right? So both 5G base stations and the LTE base stations are connected to the EPC, right? So in a layman language, you can say LTE is the master node and the 5G is the slave node. And there are options available in case of option 3. So you can see here. So you can see here option 3 little bit changed, like UE connected with 5G with the control plane, 5G is connected with LTE with the user plane. So these things, these options are there, but we don't have to go in detail. Only 3x is the most important option that we have already discussed, right? So option 3 is there, option 3A is there, right? So you can see here in this 5G and LTEs are connected only through the control plane. You can see the dotted line in the middle, right? You can see some dotted lines. So that is the control plane only. Then we have this option 3x. You can see here in this LTE and 5G are connected with user plane only, right? And 5G is connected with the EPC only by the user plane that we have already seen, right? So these are the few options we have, right? So we have 3 options, option 3, option 3A and option 3x. So how they are connected, how G node B and E node B are connected, that will decide which option it is, whether it is option 3, whether it is option 3A, whether it is option 3x. Okay. This is what I mentioned earlier, that 3x is the most preferred option, right? Because in this, user plane is connected with the EPC and the user plane is connected with the LTE. Okay. So this is the most important options. Okay, guys. So we're talking about option 3, which is the non-standalone option, right? So let's talk about one standalone option as well, which is option number 2, right? So we have talked about 3, 3A, 3X, right? So let's talk about this option 2, which is the standalone option. So the next generation RAN supports the new radio access technology, right? Or you can say RAT. So evolved E-UTRA RAT or both, with an interface between the next generation core network. So NR is the new radio access technology and E-UTRA is the evaluation of the E-UTRA to support the next generation system. So standalone new radio is one of the deployment configurations in which the next generation RAN operates using the NR RAT and has control plane connectivity to the next generation core. So we have seen in our previous slides, there are various options like option 1, right? Option 2, option 5 in this standalone, right? So option 1 is only LTE, right? And then we have these 2 options, standalone option, which is option 2 and 5. 5 is not used that much because in that 5 may not be used that much in the future because we can have only, we have core of LTE, but E node B or the BTS is of LTE. So it may not be used in the future, but option 2 will be the most used option. So you can see here we are using the 5G core, right? We are using the 5G core, and here we are using the 5G interfaces like N2 interfaces, N3 interfaces, or these kind of interfaces. And G node B and core are connected both through control plane as well as user plane for the option 2, right? So these are the option 2 standalone 5G, N2 and 5G. Okay. So we have seen many options to deploy 5G and no such options were available in case of LTE. And the solution is also called the dual connectivity. So we have seen various families, right? So we have seen family number 3, right? Which is non-standalone mode. Then we have seen the family number 2 as well, right, which is standalone mode. And there are few more options that may be finalized in the future. So you can see here, one is option number 7 and other one is option number 4, right? So these are the 4 more options may be proposed in the future. So these are not foreseen to be supported by the first phase or the second phase of 5Gs, and these are in the initial stages. So you can see here in option 7 and in option 4, I can use 5G core network, right? Here I am using the 5G core network. This red one is the user plus control plane, and this black one, or whatever the color is, gray one, is the user plane only. So in option 7, LTE is connected to the core with the user plus control plane, right? The user plus control plane in the option 7. But in case of option 4, LTE is connected with the core as well as with UE only with the user plane only. Okay, only with the user plane. Okay, so in option 7, user plus control plane, right? So, or you can say in option 7, LTE is the master and 5G is the secondary. But in case of option number 4, LTE is the secondary and 5G is the master, because 5G has the control plane as well as the user plane, right? You can see here option 4 and option 3 are very similar, or you can say they are very opposite to each other. So in option 3, EPC, we are using the LTE core, but in case of option 4, we are using the 5G core. In case of option 3, LTE is the master. In case of option 4, 5G is the master. In case of option 3, 5G is the secondary node. In case of option 4, LTE is the secondary node. So option 3 and option 4 is very easy to remember. They are very opposite to each other. So you can remember these 4 options. So standalone versus non-standalone mode. So as I said, 5G is the first radio solution closely integrated with the existing radio network, and it will offer a smooth rollout and a seamless experience for the users. So as discussed in the previous slides, there are 2 primary options for the deployment. One is NSA, which is also called non-standalone mode. In this mostly new radio or 5G is the slave mode, and LTE is the master with the core of LTE. But in case of standalone mode, we use 5G new radio under the 5G core, right? So first one is our non-standalone option, which is NSA. So from a practical standpoint, it is easy to understand why operator pushed hard to expedite the 5G NSA radio architecture with EPC. So this architecture basically can use the existing 4G EPC and 4G LTE RAN for the network coverage. So it will allow them to add 5G NR to address the network capacity constraints with the minimal changes to the infrastructure and the operations, right? So these are the various advantages, like it is available 6 months earlier than the standalone mode. We can use the existing EPC, right? And data rate can be aggregated between LTE and 5G, and we can take the advantage of VoLTE, right? At this moment, maybe you may have heard of this term called VONR, right? Voice over new radio. Right now, it is not in that use, so we can take the advantage of VoLTE in case of this NSA mode. But then we have this standalone mode. But NSA is a good option, but NSA network is not a complete 5G end-to-end network until the core supports the 5G core functions, right? So using LTE core may be a short-term solution for some operators, but it won't satisfy their long-term objectives. Simply put, with 4G core, operators can't meet the broad range of new and varied 5G service requirement with the non-standalone options. So to meet the scalability, flexibility, performance, and to cost-effective deliver 5G service, standalone is very much required. Moreover, you know that 5G requires cloud-native, service-based architecture and various other facilities like network slicing, virtualization, All these things are required, which will not be possible with the help of this NSA option. So for short term, NSA is a good option, but not for a long term. Okay. So these are the difference between standalone and non-standalone. So guys, can you answer this question? Which option will deploy in the early rollout? Very nice, very nice. Everybody is given the right answer. So the option 3 will deploy in the early rollout. And which option is called standalone in 5G? Okay, very nice, guys. That is option number 2. Okay, so let's have a summary of this 5G deployment options. So guys, have seen various deployment options in case of 5G, and these are some of the possible path to go down or for getting to where you want to go eventually, which is usually 5G core. So right now we are at the option 1, right? We are at the option 1. So we can go to the option 5 directly, right? We can use the 5G core, no need to uninstall the E-NodeB, right? Or from option 1, we can go to option 2. So just uninstall LTE, uninstall E-NodeB and use only the 5G core. Or as I said earlier, this is the most used option, which is 3x. So do not uninstall E-NodeB, do not uninstall the LTE core. Just go to the 3x option, just add G-NodeB to add the or improve the data rate. Okay, you can do it. And then there may be some other options like 3x option. We can go to this 7x option, right? Because in this case, we are uninstalling the LTE core and we are using the 5G core. Okay, and after 7x, we can go to this option like G-NodeB. So in this 7x, we have discussed that E-NodeB is the master and G-NodeB is the secondary. But after that, we can migrate to 4A, right? So these are the various paths operator can follow, right? And they can do any path, but generally they are using this path, which is option 1 to 3x. Okay, so these are the people are following in the. So this is what we have discussed: data transfer using the LTE interface. So we have two main options. One is option number 2 and other one is option number 3x, right? So in standalone option 2, a G-NodeB is connected to the 5G core and data is transferred between the G-NodeB and the UE using the NR air interface. But prior to data transfer, prerequisites such as registration, PDU session setup towards the suitable data networks and the measurement configuration need to be met. Okay, so these are the things in case of option 2. Then we have this NSA option, which is the option 3x. So in the NSA 3x, a G-NodeB, also referred to as EN-G-NodeB, right? Why EN-G-NodeB? This G-NodeB has to understand the 4G protocols. That's why it is called EN-G-NodeB. Very nice. Okay, so this is the option 3x. Okay, so again, NR-LTE dual connectivity. So dual connectivity was introduced in 3GPP. The main purpose is to allow a UE to simultaneously transmit and receive data on multiple component carriers from two cells groups, right? So two cell groups, one for providing LTE access and other one for providing new radio access, which is also called as 5G. Okay? So in this case, one scheduler is located in the master node and one scheduler is located in the secondary node. And dual connectivity, as you know, has many benefits. Like, first of all, it allows to combine the LTE and 5G data rates together. And it allows us to reuse the existing evolved packet core, right? We can use the core of LTE. And in this case, a UE is connected to one E-NodeB that can act as a master node, and it can connect to the other G-NodeB that can act as a secondary or the slave node. Okay. So what are the objectives covered in this training, in this part? So we have covered, so we have defined the 3GPP dual connectivity feature. We have seen the advantage of dual connectivity, and we have also discussed the architectural option for 5G dual connectivity, multi-rate dual connectivity, and the deployment options, right? So what's the conclusion from this dual connectivity? That dual connectivity is a feature that is just an extension of carrier aggregation, and it allows UE to receive and transmit data through 2 base stations. And higher user throughput, larger network capacity, and better load balancing and flexibility are some of the advantage of dual connectivity, which we have seen in that slide, right? But only thing is that dual connectivity improves our spectral efficiency, but complexity at the transmitter and receiver may increase, right? So these are the things we have discussed in this part of the training, right?